Hello, welcome to the SAS Global Forum 2020. I'm Xinlong Chen, and I'm the Senior Manager at SAS and the Head of Econometrics and the Time Series Analysis Group. Today, I will introduce you 3 powerful time series tools for the multiple time series analysis. They are all linked to Nobel Prize winners, Sims, Granger, and Angle. Sims introduced the vector autoregression to the macroeconomics field, and Granger put a lot of efforts on the study of cointegration, which are addressed in the vector error correction models. Angle proposed the ARCH model and later extended to the GARCH model to modeling the volatility in the time series. Let's start with the vector autoregression. When you know some variable y depend on x, you do the regression, as shown in the left plot. And when you know that the y depends on its own past, then you use the autoregression, as shown in the right side plot. But what happens if the y depends on its own past, then the other time series past, or in the other time series x depends on its own past and the y's past? Then you go to in the world of vector autoregression. If it's written in the equations, it's just on the left-hand side, you put all the dependent variables in the vector. And on the right side, and all their past. And for the innovation or the errors, now it's that on each time step, there are multiple errors and they are correlated with each other. This is the vector autoregression. Let's use the example and to show what happened. We'll model, here is the plot of the inflation, unemployment rate, and interest rate. And plot them together, and they are quarterly data, and plot them together. It's difficult to tell what's the relationship between them. So let's just put them in the vector autoregression. Here we use the procedure called proc VARMAX. And you input the data, and here we do a little bit of trick to exclude the 8 quarters data out, so that later we'll do the out-of-sample forecasting. And then you provide the ID, this is the quarterly data. And then you, in the model statement, you put your dependent variable in, inflation, unemployment rate, and the interest rate. Here, we need to do the first task for model selection, because we are not sure how much past information we should include. 1 quarter, 1 year, and 10 year. And we'll use the minimum information criterion method to help us to determine what the how many lags of data or past information we should include. And here we put in, and then as shown in this result, it shows that the 4 lag AR4 has the minimum AICC, and then it means that we should use P equals 4 in the later for our lag. In the vector autoregression, there are 2 important concepts. One is the Granger causality test. The other is the impulse response function. I'll talk later. And now for the Granger causality test, it's not the similar causality test as in the statistics or other field. It's just talking about if X could help the forecast of Y. If it does, then we said X Granger causes Y. And the test is testing it cannot help the forecast of Y. So we provide the causal statement. You just put the Y in the group 1. It's a list of variables, maybe 1, maybe a lot. And all the X variables in the group 2, like here. We have 3 variables, and we'll test if y1 and y3 could help the forecast of y2. In our example, we have 3 variables, and the all combination may lead to the 12 combination. But here we just show 6 of them, and to see if one variable could help the forecast of the other. And as shown in this result, you could see that test 1, 2, 5, 6 are all rejected at a 5% significance level. It means that unemployment rate and interest rate could help the forecast of inflation, and the inflation and the unemployment rate could help the forecast of the interest rate. But both neither inflation or the interest rate cannot help the forecast of unemployment rate. And another concept is about the impulse response function. It's a little bit complex. It's just talking about what the past shocks and have the effect on some variable. And in VARMAX, it becomes pretty easier. You could directly plot them out and also choose how many you have the interest. And like here, and it shows that when there is shocks in the inflation, and what happens, what is the effect along the time on the other dependent variables. And let's go one more step is about the model selection. Is that we know that the inflation and inflation and the interest rate cannot help the forecast of unemployment rate. Then, if we could take them out of the model, that's what happens. We will use the restrict statement to do so. After that, we could compare it to the unrestricted vector autoregression. We could see the restricted version has smaller log likelihood. It means the in-sample fade decreases, but it does have the better AICC. And here is the forecast for the after sample data. Now let's shift gear to the vector error correction model. One interesting fact is that in real world there are lots of non-stationary time series, but most of the models are for the stationary time series. What's wrong with the non-stationary time series? Let's see. These 2 time series are not stationary. They seem to have share some common trend. If you do the regression and you see everything seems good, but you plotted the residue out, it's not that good. If you test it, it's unstationary. It's non-stationary. Then it means we might have something totally wrong. In fact, if we plot the next 1,000 observations, we could see these 2 time series doesn't share any trend. And in fact, the 2DGB shows one is the random walk of normal distribution, the other is the random walk of uniform. They are uncorrelated at all. Then for this important question, Granger provided lots of details, and his research on the cointegration. It means that there is some, we call it a long-run equilibrium, existed in the economic theory. We should use them to model these non-stationary time series. And if we could find a linear combination of these non-stationary time series and later lead to a stationary time series, then we should use this information. And about how to test it, and we provide in the cointer test option, and I don't talk about them now. And let's just see how to use this cointegration information in the vector error correction models. And after differentiation, it's pretty easy to get the stationary one as shown in the red. It's data YT, and the long-run relationship modeled in the green one, beta prime YT minus 1. And then all the short-run relationship and could be introduced from the A times the data YT minus 1. So it means that in the vector error correction model, it's pretty simple, but it incorporates both the long and the short-run relationship in the model. And we give an example on the purchasing power parity, and it is just talking about in the US, if you spend $1.50 for a bread, and then in the UK, you may spend that, oh, that's a typo, 80 cents for the 80 pounds, 0.8 pound for the bread. Then for the same bread, these $2 values and our currency values should be the same. So then it means that the exchange rate over the so-called price index should be a constant. This is the PPP. And we put it in log in, and then the log exchange rate minus the log price index should be some constant. This is the long-run equilibrium. We plotted the log price index and the log exchange rate in here, and then this looks like share some same trend. And put it in the vector error correction model. We use the cointeg statement. And as shown here, yes, and the estimated result shows in the green boxes. It's we catch the long-run relationship, and in the blue boxes, we're talking about we catch the short-run relationship. So in the vector error correction model, we get both of them. And here is the out-of-sample forecast. It's pretty good. Now let's talking about the GARCH models. Most of the financial time series, they have one common fact is that their volatility seems time varying, and there is a fact is called volatility clustering. The big volatility follows the big volatility, and the small volatility follows the small volatility change. And here is the two plot of the Japanese market and US market. You could see this one. And how to model it, we'll talk about later. But the first thing, let's link the risk to the volatility. And in most cases that we use volatility to measure risk, but why? Here is a quick example. And for example, you working on the investment, and then and when you invest on the stock, here is the example. The expected return is a little bit positive, the 0.275%, and the standard error is pretty big, 1%. And if you invest on this one, and then you have a big chance, 39% chance to get in some negative returns. It's showing in the red area. And then is the risk. You get some loss. So we quickly link the standard deviation to the risk. And the bigger of the standard deviation, then you have a bigger risk to get some negative return. And how the correlation get in. If you could, that first focus on that all these things have all these stocks have no correlation with each other. Now, if you could find 10 such stocks, then even they have the same expected return, same standard deviation, but your risk to get some negative returns would dramatically decrease to the 19%, half. If you could find 100 such stocks, in fact, just 0.3%. If 400 such stocks, you almost sure could get the 0.275% positive return. And if there exists some positive correlations between these stocks, and it means that you need to find more such stocks to make sure you have the positive return. And if there is a negative correlation, and you just need a very few stocks, but still to make sure you have that positive return. So this means the correlation has a big impact on your risk of loss. So now we know how the risk linked to the volatility. We could focus on how to model or forecast such volatility. We'll use the so-called dynamic conditional correlation, GGR GARCH 1.1 model. This is a long name, but in fact, it's just talking about the mainly two parts. One is that for each time series, you will use the GGR GARCH 1.1 on it. The GARCH 1.1 means that it only focuses on the current volatility. Only depends on the previous volatility and the previous squared innovation. And the GGR part is talking about news impact, and we'll talk about it later. Then the second big part is the DCC part, dynamic conditional correlation. It means that we do think the conditional correlation would change over the time. Let's see if that's true. In the proc VARMAX, now you need to use the GARCH statement. You just define the DCC in the form, and the GGR in the start form, and P equals 1, Q equals 1 for the GARCH 1.1, and you can even output all these conditional volatility in the after HT option. We'll keep going on. Here is the estimation result. Let's first talk about what means the news impact curve. And we use the GGR just because we do believe that the negative shocks in price and the positive shocks in price should have different impact on the future volatility. In fact, as shown in this plot, that's true. And now let's see the other parameter. It's about the dynamic conditional correlation versus the conditional constant conditional correlation. We could see DCCA and DCCB in the red box. They are both significant, and in the plot we could see that the correlation does change over time. So we choose the right model, but how to use it? Why does it matter? We use the example of in the portfolio optimization. For the trading, most of the time, it should be the risk and the return trade-off. And here we use one of the objective function. We want to maximize the return at the same time to minimize the risk. And the balance, we use the gamma is about your risk averse attitude, and then to put them together, and now you have just one objective. And about the return, and we use the momentum factor. This is the one of the paper is cited more than 12,000. So and for the volatility part, in fact, the big sigma, and we'll use what we get from our DCC GARCH model. And put them together, and we tested against the three benchmark strategies. There are you only hold Japanese, or only hold US, or you just equally hold both of them. And the test period is 55 years. As you could see, this is the wealth curve. It means that in 1955, if you have only that $1, and after 55 years, and the different strategy lead you to the different wealth value. We could see the green line is our strategy. We balance the risk and the volatility. It's about 60% better than the second best. And here is the table to show the same result. We're also talking about the Sharpe ratio. It's And here we introduce you the vector autoregression, vector error correction models, and the multivariate GARCH models. Later, I hope that I have a chance to introduce you the Bayesian features in the PROC VARMAX or the other two more complex models for multiple time series analysis. They are statistics model or hidden Markov model. If you have any questions, please just send me the email or ask now. Thank you.